The arrival of an unexpected visitor from another star system, streaking unannounced through the inner regions of our solar system, naturally generates enormous curiosity, excitement, and speculation among scientists and the general public alike. Interstellar objects are incredibly rare, and before recent years, humanity had never directly observed one passing through our planetary neighborhood. The third such interstellar traveler ever identified, officially named 3I/Atlas, has therefore become the subject of intense interest. Some people have gone so far as to suggest that this mysterious body might be an alien craft or an intelligently designed probe sent from a distant civilization. These ideas, while imaginative, have no scientific basis. Instead, a steadily growing body of detailed observations strongly confirms that 3I/Atlas behaves exactly as a natural comet would, not as an artificial spacecraft. Every new image, measurement, and analysis reinforces the conclusion that this object is simply a fragment of frozen material wandering between the stars, not a messenger from an extraterrestrial intelligence. Multiple observatories around the world, including Gemini South, have contributed to our understanding of this interstellar comet. As part of the NOIR Lab Educational Observing Program, astronomers have used highly sensitive instruments to examine its structure, brightness, and behavior. These observations reveal unmistakable signs of a real comet, a clear coma of dust and gas surrounding the nucleus, as well as an extended tail created as the object approaches the sun. These features are not illusions, distortions, or photographic errors. They are genuine physical phenomena produced by the sublimation of volatile materials, primarily water ice, carbon dioxide, ammonia, and other frozen compounds, contained within the comet's core. When heated by the sun, these ices turn directly into gas, carrying dust grains with them. The released gas spreads out around the nucleus, forming the glowing coma, while solar radiation pressure and the solar wind push the dust away to create the sweeping tail characteristic of comets. No asteroid behaves this way, and no spacecraft would be designed to shed material uncontrollably in such enormous amounts. The visual appearance of 3I/Atlas alone distinguishes it from an asteroid. Asteroids are rocky, solid objects lacking volatile ices, and therefore they do not produce comas or tails. A spacecraft, especially one designed by an advanced civilization, would be expected to maintain a stable shape, structural clarity, and predictable visibility. The fuzzy, diffused cloud around 3I/Atlas contradicts what one would expect from a constructed, metallic probe. Furthermore, the tail observed is large, bright, and dynamically evolving, responding naturally to solar heating rather than to mechanical forces or engines. These natural reactions to sunlight reinforce that we are witnessing typical cometary physics, rather than artificial propulsion systems or controlled actions. In addition to its physical makeup, the motion of 3I/Atlas further confirms its natural origin. Scientists studying its path have observed no thrust, no course corrections, and no deviations from a simple gravitational trajectory. It travels exactly as any object from deep space would, following an orbit shaped solely by its initial velocity and the gravitational influence of the sun. A spacecraft, even if powered down, would likely exhibit some maneuverability or detectable technological signature. If it were on a mission to study planets or solar bodies, it would probably adjust its course to approach Earth or other targets. Instead, 3I/Atlas glides through the solar system at tremendous speed, unaffected by anything except natural forces. It does not display any of the hallmarks of intelligent control. Even more telling is the object's interaction with sunlight. As 3I/Atlas entered the inner solar system, the increased intensity of solar radiation caused its frozen ices to sublimate at a faster rate, creating more gas and dust. This is exactly what astronomers expect from a comet making a close pass by the sun. Natural comets behave this way constantly, brightening and developing more pronounced tails as they get closer to the sun. The observed activity matches well-established cometary models and shows no irregularities that would suggest artificial materials or engineered systems. The object's reflectivity also aligns with its identity as an icy body coated with dust, rather than metal or composite materials associated with spacecraft construction. The idea that 3I/Atlas might be an alien spaceship often comes from sensational interpretations rather than scientific evidence. People unfamiliar with cometary behavior may find the object's appearance mysterious, especially given its interstellar origin. However, space is filled with countless icy bodies wandering between stars, remnants of planetary formation processes that occur in star systems across the galaxy. Most never come near another star, but occasionally gravitational interactions or collisions eject them into interstellar space. Over millions or billions of years, some eventually drift through our solar system. That is precisely what scientists believe happened with 3I/Atlas. Its structure, speed, and chemical composition align seamlessly with this natural explanation. Moreover, if an advanced civilization had sent a probe across interstellar distances, it would likely be equipped with technologies making it detectable in ways very different from a comet. Artificial objects tend to emit radio signals, thermal signatures, or other signs of engineered activity. No such signals have been detected from 3I/Atlas, despite careful monitoring by observatories capable of picking up even faint transmissions. Its chemical content, determined through spectral analysis, shows no evidence of manufactured materials. Instead, it displays the same ices and compounds common in comets originating in our own solar system. The dust surrounding the nucleus is irregular and chaotic, not structured or mechanically produced. Additionally, the behavior of the gas streaming from the comet matches the natural physical laws governing sublimation. The coma thickens and thins depending on its distance from the sun, and the tail's orientation shifts according to the influence of solar radiation. These factors all act predictably and mathematically, just as they do for every other known comet. Researchers can model the outgassing patterns with standard cometary equations, and the results align perfectly. If the object were artificial, we would expect non-natural patterns, such as controlled jets or propulsion signatures. None exist. Another important point is the simplicity of 3I/Atlas's path. It does not slow down as it approaches the sun, nor does it perform any maneuvers that might indicate scanning behavior or targeted exploration. Instead, it moves at high interstellar speed, passing briefly through our region before returning to the vast emptiness between stars. A spacecraft designed for exploration would likely approach planets more closely, potentially enter orbit, or adjust its flight path to gather more information. 3I/Atlas does none of these things. It simply passes by and continues onward, unaffected by curiosity or intention, just as a natural object would. This is not the first time interstellar objects have sparked interest or speculation, but each new discovery highlights the richness and complexity of our galaxy. Rather than being evidence of alien engineering, these objects remind us that star systems form in diverse environments, producing debris that can travel incredible distances. Studying these wanderers helps scientists learn about the building blocks of planets, the distribution of chemical elements in different regions of the galaxy, and the processes that shape solar systems. Interstellar comets, like 3I/Atlas, may carry clues about the early conditions of distant stars, offering a unique scientific opportunity. Far from being a threat or a hidden spacecraft, 3I/Atlas is a natural ambassador from another part of the galaxy, an icy relic created long ago in a star system far from our own. Its journey into our solar system allows astronomers to study materials that originated light years away, giving valuable insight into the diversity of cosmic environments. Its behavior, appearance, and chemical composition all align with what we know about comets, and nothing in its observed characteristics suggests artificial origins. Thus, the evidence overwhelmingly supports the conclusion that 3I/Atlas is a natural interstellar comet. Its coma and tail are produced by sublimating ices. Its trajectory is governed solely by gravity. Its reflectivity, composition, and activity patterns are typical of frozen bodies heated by the sun. And its complete lack of controlled movement structural clarity, or technological signals confirms that it is not an alien probe. Rather than fueling speculation about extraterrestrial craft, 3i/Atlas adds to our growing knowledge of interstellar objects and strengthens our understanding of the dynamic and interconnected nature of the galaxy we inhabit.